Welcome dear learners. We are continuing Unit 5 Inorganic Chemistry Practicals 1, Volumetric Analysis. We are now starting experiments. In this module we are discussing experiment number 1, that is strong acid versus strong base titration. For typical example, we are taking the titration of hydrochloric acid against sodium hydroxide. The contents of this module are neutralization reactions, acidimetry and alkalimetry, hydrochloric acid against NaOH titration, indicator selection, reagents required for the titration, procedure, demonstration of the experiment, calculation and results. We can enter into the experiment number 1. Before starting the experiment, we have to discuss various aspects associated with the experiment. For that, we are beginning from neutralization reactions. A neutralization reaction is a type of chemical reaction in which an acid and a base react to form water and a salt. This reaction typically occurs in aqueous solutions and involves the combination of H plus ions from the acid and OH minus ions from the base to form water molecule. That is, H plus and OH minus combines together to produce H2O. General equations for neutralization reaction is acid plus base produces salt and water. The acid may be strong acids like HCl, H2SO4, etc. or weak acids like acetic acid or CS3COOH. The base may be strong base like sodium hydroxide, potassium hydroxide, etc. or weak base like NH4OH. Thus, theoretically, there are 4 types of neutralization titrations. Now, we are discussing the theoretical aspects associated with acid-base titration, that is nothing but acidimetry and alkalimetry. Acidimetry and alkalimetry refers to titrations involving acids and bases in volumetric analysis. In acidimetry, the quantitative analysis of basic or alkaline substances using a standard acid solution is performed. In alkalimetry, the quantitative analysis or alkalimetry is a quantitative analysis of an acidic substance using a standard base solution. You are familiar with the standard solution. A standard solution is a solution with exactly known concentration. The basic principle of acidimetry and alkalimetry is neutralization. That is the reaction between acid and base to produce salt and water. Equivalence point is very important as far as every volumetric analysis is concerned. What do you mean by the term equivalence point? It is the point at which the amount of acid equals the amount of base in acidimetry or alkalimetry or in a neutralization reaction. End point is somewhat different from equivalent point. End point is the point at which the indicator changes color, signaling the completion of the reaction. That is, end point is very close to equivalence point. In order to find out the equivalence point, we are using some indicators. So, near the equivalence point, the indicators will showing some color change. That point is taken as the end point. End point never means the equivalence point. End point is very near to the equivalence point. Now we can take our present experiment, that is HCl against sodium hydroxide titration. That is, we are going to perform the titration reaction between hydrochloric acid and sodium hydroxide. Hydrochloric acid HCl against sodium hydroxide titration is a typical example for a strong acid against strong base titration. The double burette method can be used for the titration. Double burette method has several advantages over single burette titration. This major advantage of the double burette titration is the minimum consumption of the chemicals, and determination of the endpoint is more accurate if you are using some graphical method. So, double burette method of titration has several advantages over single burette titration method, and for the demonstration and description of the present experiment, that is experiment number 1, that is the titration of HCl against NaOH, we are using the double burette method. Aim of the experiment is here. Estimate the weight per liter of the given sodium hydroxide solution. You are provided with n by 10 HCl solution. N by 10 means 0.1 normal hydrochloric acid solution. Principle: hydrochloric acid reacts with the sodium hydroxide as per this equation. HCl plus NaOH produces NaCl plus water. Here you can see the reaction between an acid and a base to produce salt and water. So, this is clear-cut example for a neutralization reaction. The equivalent mass of NaOH and HCl are equal to their molar masses, and this principle is used for the estimation of sodium hydroxide. The unknown concentration can be calculated using the formula NHCl into VHCl equal to NaOH into VNaOH. This is similar to the common volumetric equation, that is N on V1 equal to N to V2. And in this expression, NHCl represents the normality of hydrochloric acid and VHCl represents its volume. NaOH represents the normality of sodium hydroxide and VNaOH represents its volume. Now, we can have a discussion on indicator selection before starting the experiment. Common acid-base indicators are here. Methyl orange and phenolphthalein are very popularly or commonly used acid-base indicators. This table will guide you for the indicator selection and the color change. Methyl orange has a pH range of 3.1 to 4.4, and the color change from base to acid medium is yellow to red. However, for phenolphthalein, the pH range is from 8.3 to 10, and here the color change from base to acid medium is pink to colorless. That is, in basic medium it is pink, and in acid medium it is colorless. There are several kind of titrations: strong acid, strong base titration, strong acid, weak base titration, etc., etc. And you have to take an adequate indicator, and you can directly pick the suitable indicator from the chart itself. The titration type, strong acid against strong base titration, you can use both the indicators, and the endpoint has a pH of 7 that indicate neutral pH. However, for strong acid against weak base titration, the suitable indicator is methyl orange and the pH is less than 7 at the time of the completion of the reaction. Weak acid against a strong base can be titrated by using phenolphthalein indicator, and at present experiment we are discussing the titration of a strong acid against a strong base. So, you can use either phenolphthalein or methyl orange. That means both indicators are suitable for the present titration. Now, in the present experiment, to demonstrate, we are taking phenolphthalein as the indicator. And the color change you have to note, the color change is pink to colorless. That is, the phenolphthalein is pink in basic medium and colorless in acid medium. Now, before starting the experiment of hydrochloric acid against sodium hydroxide solution, we are first look onto the reagents required for the titration. The reagents required are 0.1 normal HCl solution, that is n by 10 normal HCl solution, approximately n by 10 sodium hydroxide solution, this is for estimation, and phenolphthalein indicator. Now, we are discussing the procedure before starting the experiment. Set 2 burettes, burette 1 with hydrochloric acid and burette 2 with sodium hydroxide. 16 ml of sodium hydroxide is added to the conical flask from burette 2. 1 drop of phenolphthalein indicator is added. It is then titrated against hydrochloric acid taken in burette 1 and the end point is determined. From the titer value, we can calculate the normality of the unknown concentration using the relation VHCl into NHCl equal to VNaOH into NaOH. To the solution left in the conical flask, 2 more ml of sodium hydroxide is added from the burette 2. It is again titrated against hydrochloric acid from burette 1 and determine endpoint and calculate normality as you have done in the just previous addition. The process is now repeated for 20 ml, 22 ml and 24 ml of sodium hydroxide and normality is calculated in each step of the reactions. Average of all these values of normality is taken as the normality of the unknown solution. Moreover, graphical method can also be adopted to determine the unknown concentration. Now, we are demonstrating the double burette method of titration of hydrochloric acid against sodium hydroxide. Now we have completed the experiment, and the last part of the experiment number 1 is the calculation and reporting of the results. The titer values obtained in the previous titration can be tabulated like this. This is about the serial number in the first column. Volume of sodium hydroxide, first of all we take 16 ml and you got the corresponding titer value as 16.3. You can calculate normality based on the equation N1V1 equal to N2V2 or NaOH into VNaOH equal to NHCl into VHCl. You will get a corresponding normality of NaOH as 0.1019 normal. And in the second case, you add 2 more ml of sodium hydroxide. So the volume of sodium hydroxide is now 18 ml. Corresponding titer value will be 18.3. You can calculate normality as 0.1016. Similarly, you tabulated all the titer values and corresponding normalities in the table like this. And normality calculated using this expression, normality of NaOH is calculated using the expression NaOH is equal to NHCl into VHCl divided by NaOH. That is, the last column is filled by using this expression. So, the details of the experiment are tabulated and the normality is calculated. Now, the normality of NaOH solution is simply the average of all the values given in the last column. So, the average normality of NaOH equal to 0.1019 plus 0.1016 plus 0.1020 plus 0.1019 plus 0.1016 divided by 5, since you are measuring 5 normalities and you are getting the normality of the solution as 0.1017. Now, weight per liter of the given NaOH solution can be calculated by using the expression weight per liter is equal to normality into equivalent weight. Normality is calculated as a 0.1017, just to multiply with the equivalent weight of sodium hydroxide, that is equal to 40. So, you are getting the weight per liter as 4.068 gram per liter. Graphical method can also be used to find out the normality of NaOH. For this purpose, you have to plot the volume of HCl in the y-axis against volume of sodium hydroxide in the x-axis. The graph will give definitely a straight line and you can calculate the slope. Normality of NaOH and NaOH will be theoretically equal to normality of HCl multiplied with the slope. Thus, the final result of this experiment is shown here. The normality of the given NaOH solution is 0.1017 normal. Also, the weight per liter of given NaOH solution is 4.068 gram per liter. That all about experiment number 1. Have a nice learning experience. Thank you.